Hello everyone, my name is Priyanshi Jain and I'm here to talk about a topic called deadlock and operating system. Let's start with what is deadlock. When there is a multi-programming system, lots of processes starting to competing together. And when they started competing together in terms of resources, there has to be a situation जब एक process को resources नहीं मिल पाते. And this is where process goes to a waiting time. जब ये waiting time indefinite हो जाता है, when the waiting time goes to indefinite because the resources the process needs, those resources are with some other processes, that's where the deadlock occurs. Let me read this slide. Processes are halted, each holding a resources. They wait resources held by together. Circulatory dependency. A vicious cycle of waiting forms. No process can advance, and system inefficiency. Resources are tied up. The system grind to halt. Four conditions for deadlocks. Why these processes are not getting the resources, what is taking them, why the period time is indefinite. The reason is because of these four conditions. Now, is it necessary that these four conditions should be there? Yes. If one of the condition is not there, then deadlock won't occur. Let's talk about the first condition, which is called mutual exclusion. In mutual exclusion, those resources which are non-shareable, for example, a printer. If a program or what can say process A needs a printer, but a process B also needs a printer. Now, printer is only one. That means both of the process, only one process is gonna get a printer. That means a mutual exclusion. Second, hold and wait. One process needs two resources. Okay. That process gets the first resources. Okay. Now it's gonna wait for the second resource. Until then, it's gonna hold the first resource which the process had. For example, if you are going somewhere to eat and there is chapati and sabji, okay, and you want to eat food. So now chapati has been arrived. So you first take the chapati. Now you are waiting for the sabji. Agar if you wait that chapati and sabji will both come together, then उसमें बहुत time लग जाएगा, right? तो अपन चपाती को hold पे रख रहे हैं, and then we are waiting for the sabji. That's the same thing happens in hold and wait, where processes hold one resource and it waits for another. Second, no preemption. If priority has been given to the process, तब तो बहुत easy है. पहला priority इसका है, the process will work. Whatever the second priority will be, then that process will work. But here, what's happening? Here, the thing is that yeah, sorry. Here, the thing is that there is no preemption. There is no priority given. Sara ka sara process are treated equally. That is the reason resources cannot be taken. They are released voluntarily. Now, the fourth and the main thing. For example, अगर ये तीनों चीज हुई mutual exclusion, wait and hold and preemption, तब भी the problem will occur. For example, a P1 needs a resources that have in P2. Now P2 needs resources जो P3 के पास है. Do you think the deadlock will occur? No, because P3 is not waiting for any other resources. But in a case where P3 is also waiting for resources which has or with P1, then there is a circular loop forms. Every process is waiting for something to come up. And then there is a chain which never going to get break. A closed chain of process, each waits for the next. That means circular wait. That is why these four conditions are needed. Very, very necessary conditions to form a deadlock. Now, what are the types of deadlock? There are two types of deadlock. One is hard deadlock and second one is soft deadlock. Hard deadlock means if all those four conditions are there and there is completely halt, अपन कितना भी try कर ले, कितना भी try कर ले, we are not gonna get out of that situation. A process will be going to have indefinite waiting time, will be deadlock. because it's a circular dependency, which I talked about. P1 needs P2, P2 needs P3, and P1, P3, P1 and P3 both needs each other. So it's gonna get a deadlock. That hard deadlock cannot be resolved. The second is soft deadlock. Means yes, process is eventually gonna get started. Okay, like right now it's in halt. Yeah, the waiting period of time is there, but it is not indefinite. It is definite. You can solve it. The delay might occur. There might be buffering. There might be delay, but at the end the process will work. That is called soft deadlock. Now we're gonna talk about causes of deadlock. Now, these were the four conditions that caused the deadlock. Now we're talking about चलो ये condition अगर नहीं भी हुई तो क्या क्या चीज होती है उससे भी deadlock अगर होना इन conditions पे आ जाता है. The first is resource contamination, means multiple processes vie for a limited resource, which is called mutual exclusion. For example, which I gave you of printer, it's saying same that कि multiple process को एक ही resource का need है, and that is the thing may might cause a deadlock. Second is incorrect in allocation. For example, distribution ही सही नहीं है, indexes ही सही नहीं है. A process doesn't know where to go. If process is going there, another resources is somewhere else. That means allocation जब incorrect होता है, there is a may happen, there is a situation जिसमें delay होने लगता है. That is called incorrect allocation. Third is synchronous request. Process request resources simultaneously. All the process concurrently एक ही टाइम पे जब रिक्वेस्ट भेजती जाएगी तब deadlock might occurs. The next is uncoordinated sync, which is basically same like in incorrect allocation. Allocation different हो गया. अब क्या हो गया? Sync नहीं हो पा रही है. Proper process है ही नहीं coordinate करने की, तो it's not going to get work, right? The next is how can we prevent. तो जो चार कंडीशंस है उन चार कंडीशन का अगर आप अपोजिट करने का ट्राई करो तो डेडलॉक माइट नॉट अकर, राइट? अवॉइड होल्ड एंड वेट. रिक्वेस्ट ऑल रिसोर्सेज एट वंस. इफ अ प्रोसेस होल्ड्स वन थिंग, ठीक है, वेट फॉर द अनदर. इंस्टेड ऑफ दैट, इफ ऑल द प्रोसेस का रिक्वेस्ट आप करो और इकट्ठा आपको मिल जाए, आपने अवॉइड कर दिया होल्ड एंड वेट. अवॉइड सर्कुलर वेट, ठीक है. इम्पोज अ रिसोर्स ऑर्डरिंग. मेरे को ये ऑर्डर अगर पहले ही क्रिएट हो जाए तो जो चेन होगी डिपेंडेंसी की वो ब्रेक हो जाएगी. एंड थर्ड, यू प्रीएम्पशन मीन्स यूज प्रीएम्पशन मीन्स गिव प्रायोरिटी. इफ देयर इज फॉर एग्जांपल अ प्रायोरिटी, कोई सा भी प्रीएम्पशन है तो क्या होगा? वर्क होने लग जाएगी चीजें. नाउ, रिकवरी फ्रॉम अ डेडलॉक. ठीक है. नाउ, प्रोसेस टर्मिनेशन एंड रिसोर्स प्रीएम्पशन. ठीक है. प्रोसेस टर्मिनेशन मतलब जितने भी होल्ड रिसोर्सेज हैं, जितने भी रिसोर्सेज है आपने हेल्ड करके रखे हुए हैं उनको आप रिलीज कर दो. जब आप रिलीज कर दोगे एक ना एक प्रोसेस जो होगी वो वर्क होगी. और अबॉर्ट कर दो डेडलॉक प्रोसेसेस को, टर्मिनेट कर दो, प्रोग्राम को बंद कर दो. सेकेंड इज रिसोर्स प्रीएम्पशन. दैट मीन्स अलोकेट द अदर्स, टेक रिसोर्सेज फ्रॉम द प्रोसेसेस और आप दूसरी प्रोसेसेस को दे दो. यही चीज है. नाउ, numerical examples. This is a nice example. For example, in this example, we are considering A, B, C and processes P1, P2 and P3. ठीक है. जो P1 resources है उसने करा हुआ है होल्ड है, P2 ने होल्ड करा हुआ है B and P3 ने रिसोर्स होल्ड किया हुआ है C. ठीक है. Now, a P1 resource is waiting for a B, that means a P2 resource, right? And P2 resource is waiting for something which is holded by P3, and P3 resource is waiting for P1. अगर अपन normally P1, P2, P3 को इकट्ठे चलाए तो what's gonna happen? Of course, there will be a deadlock, right? There is gonna be a circular wait, right? For example, a P1 to P2, P2 to P3, this is called. Now all the processes जो होती है यहाँ पे क्या हो जाएगी? ब्लॉक. एंड इसका मतलब ये क्या लीड करेगा? डेडलॉक. नाउ लेट्स कंसिडर कौन कौन सी कंडीशन हो रही है. पहली चीज म्यूचुअल एक्सक्लूजन. व्हाई म्यूचुअल एक्सक्लूजन इज हैपनिंग? सी, देयर इज ऑब्वियसली सम लिमिटेड रिसोर्सेज, दैट इज व्हाई चीजें शेयर्ड हो रही है. ठीक है. सेकंड, होल्ड एंड वेट. Obviously, this process is holding something and waiting for something else, because here we can clearly see is that a P1 process is waiting for P2 and P2 resources is waiting for P3. Second, non-primitive. The thing is that if this process be preemptive, that means कुछ भी गड़बड़ नहीं होता, अपना अपना प्रायोरिटी होता, अपना अपना allocation होता, and direct the process would have worked. But now it is not working. The reason it is not working is because there is no setting of priority. Everyone, every process is treating equally to each other, and that is the reason there is obviously non-preemptive. It is given. Fourth is circular weight. We can already see that P1 P2 से belong करता है, P2 P3 चाहिए, P3 को P1 चाहिए. This forms a circular weight, and that is why इस proper चीज को अपन क्या बोलते हैं, deadlock. Now, prevention versus avoidance. अपन क्या क्या prevent कर सकते हैं and क्या क्या avoid कर सकते हैं challenges को, if we don't want that our process को deadlock लग जाए. पहला है प्रिवेंशन बेनिफिट्स. सिंपलर टू इम्प्लीमेंट, नो फ्यूचर रिसोर्स प्रिडिक्शन, गारंटीड नो डेडलॉक, लोअर कंप्यूटेशनल कॉस्ट. ठीक है, अगर अपन ने डेडलॉक को प्रिवेंट कर लिया तो अपन को क्या क्या बेनिफिट होंगे. फटाफट कोई भी प्रोसेस जो होगी वो इम्प्लीमेंट हो जाएगी, राइट. अपन को कोई भी प्रिडिक्ट नहीं करना पड़ेगा कि ओ आई गोइंग टू गेट दिस रिसोर्स, मे बी मुझे ये रिसोर्स लग जाएगा, मुझे कोई भी दिक्कत नहीं होगी. नो फ्यूचर रिसोर्स प्रिडिक्शन लगेगा. थर्ड इज गारंटीज नो डेडलॉक. अगर प्रिवेंट हो गया, मैंने एक कंडीशन से मैं आगे बढ़ गई, मुझे म्यूचुअल एक्सक्लूजन नहीं मिल रहा है, मुझे होल्ड एंड वेट नहीं मिल रहा है, इसका मतलब मुझे गारंटी है मुझे डेडलॉक नहीं होगा, क्योंकि चार सिचुएशन हैज टू बी देयर. एंड लोअर कंप्यूटेशनल कॉस्ट. गड़बड़ नहीं होगी, द कंप्यूटर कॉस्ट विल बी लोअर. अवॉइडेंस चैलेंज. जब जब अपन चीजों को अवॉइड करना है, इफ आई वांट दैट डेडलॉक शुड नॉट हैपन, देन क्या क्या चैलेंजेस मुझे फेस करने पड़ेंगे. First is higher overhead. Second is required a future knowledge. Obviously, if I want that deadlock should not happen, I should know कि क्या हो सकता है in future, what processes मेरे को दिक्कत दे सकती है, what other resources I might not get. Maybe that process will get into a waiting period or not. We need to know everything. Harder in real system. If you're going to talk about practical and real system, obviously it's going to harder if I cannot predict what's going to happen next, right? And can reduce efficiency. It's going to take so many power, it's going to say so many memory, it's going to say so many calculation that it can reduce an efficiency. And from there, I'm gonna conclude the deadlock. Easiest thing बस यही है deadlock की, कि the process basically जब multi programming में different different processes होती है, वो compete करती है एक resources को जो limited होता है. जब वो compete करती है तो वो waiting period of time पे हो जाती है, and अगर वो waiting period time indefinitely increase हो जाए and कभी भी वो process जो है वो terminate ना हो पाए, वो process जो होती है वो fully active ना हो पाए, उस प्रॉब्लम को बोलते हैं डेडलॉक. जो चार मेन कंडीशन से होती है. वन इज म्यूचुअल एक्सक्लूजन, द सेकेंड इज जो अपनी होल्ड एंड वेट होती है, द थर्ड इज नॉन प्रियम्पटिव, एंड द फोर्थ इज सर्कुलर वेट. थैंक यू एवरीवन.